Welcome to Easy Elimu Learning Simplified. My name is Eric. I'll be taking you through this topic, decimals, and for this lesson, we'll be looking at recurring decimals. So we will start by looking at what recurring decimals are. We'll look at the symbols used for recurring decimals, and after that, we'll look at how recurring decimals can be converted to fractions, and then at the end of the session, we'll be able to give you some assignment to help you with practicing and also to help you check your understanding of the concept as discussed through this session. So uh, as it has been discussed previously in the previous slides, we talk about recurring decimals as non-terminating decimals that have repeated digits or repeated patterns. So you can have, for example, 0.2222. You can see this is non-terminating. That 2 can continue endlessly. But then you can see 2 is repeated, or you can have a pattern that is repeated, or 2, 4, 2, 4, 2, 4. You can see that 2, 4 is repeating itself if you have such, or you can have maybe 0.242, 242, 242. So you must have a pattern that is repeating itself endlessly. So that is when you talk of a recurring decimal. So it's a type of a non-terminating decimal that has got some pattern being repeated, either digit being repeated or a pattern that is being repeated. So we have examples of recurring decimals here. So for normally say for recurring decimals, we cannot write all the digits. We therefore place a dot above a digit that is recurring. And then if more than one digit recurs in a pattern, we place a dot above the first and the last digit in the pattern. So you can have maybe 0.01253. So if it is 5353, like that is a repeated pattern, that 53, for example, then instead of writing all the digits, you simply write 53, and then you a dot on top of this and a dot on top of the other one, 5 and 3, to mean the pattern 53 is repeated. So other than that, you can come across some other literature where it is just a line above the 2, like it is in this case here. So this means 53 is being repeated, 53 is being repeated. Or if it's a pattern of 3 of 3 digits, let's say 0.243, 243, 243 is repeated endlessly, then you don't have to write all the digits. Just write, put a dot on top of 2 and a dot on top of 3. So that means this pattern 243 is being repeated. The pattern 243, 243 is being repeated. So some other books or another different way of expressing this is just drawing a line on top of the 3 digits. That means all of them are being repeated. So you can use a dot on top of the first digit and a dot on top of the last one to mean the entire pattern is being repeated, or just a line, like you can see here. So this 752, 752 is being repeated. The first one here is 53, 53 being repeated. So 53, 53, 53. So like in this other one here, it's only 3 that is being repeated. So you can see it's 22.3333. So 3 is being repeated. So you can have a dot on top of 3 or just that line. You see, so like in B, 1.752752. So that 752 is being repeated. So you can have a dot on top of 7, a dot on top of 2, or just a line in top of the 3 digits. So again, you can see. So you can have a dot on top of 1, or just that line, a dot on top of 2, or just line, a dot on top of 1 and 3, or a line on top of the 3 digits. Again, 2, 3 is being repeated there, as you can see. So first example here, express the following recurring decimals as fractions in their simplest form. So we want to see how you can express recurring decimals to fractions. We've looked at how decimals can be expressed to, or can be converted back to fractions. And now we want to see how recurring decimals can be converted back to fractions. This is normally done differently. It's a bit different from how we did the other decimals, other ordinary decimals. So here you see dot on top of 6 means that 6 is the one that is recurring. So this one is 0. 0.6666666. So 0.66666 is being repeated here endlessly. So that is how recurring decimals are represented using symbols. We say the symbols used to represent recurring decimals. So if you see that, you should be able to interpret appropriately. So I want to start with the first one. So normally, when you want to express a recurring decimal as a fraction, what you do, you let the fraction to be a letter. Let the fraction be a letter like x. So remember, I'm doing a here. So that x represents 0.66. Maybe I can use 4 or 6 digits, depending on how long the pattern is. In this case, it's only 6 that is repeating, so 4 can still work. Then you multiply both sides by 10 repeatedly until when you have a pattern after the decimal point, the same in any two of the cases. So let's multiply both sides by 10. So this side, if you multiply by 10, we'll get 10x. The other side, if you multiply by 10, it will be 6.666. I'm only writing 4 digits after the decimal point. So you're supposed to continue with that multiplication by 10 successively until when you have a pattern in any two cases. Like in this case, the pattern of decimal point is the same to this other one here, 6666. When you get that pattern, you stop. So what do? You subtract the two cases where the pattern of the decimal point is the same. So you subtract the two. And if you're subtracting, you subtract the smaller one from the bigger one. Like I will subtract x from 10x. So it will be minus x, but now I will write it as minus 1x. The other side will subtract 0.6666. So I try to make the numbers after the decimal point to be the same in both cases. Remember, I'm subtracting. So this other one, 0, 0, 0, 0. And if you subtract, this is 6. Now, x is subtract from, 1x here you subtract from 10x will be 9x. So it means then x is going to be, so you can now divide both sides by 9. So left hand side you divide by 9 is x. Right hand side you divide by 9 will be 6 over 9. And that becomes the fraction. So what you need to do is to write it in its simplest form. So I have x is equals to 6 over 9, which is equals to, so 3 can divide both numerator and denominator. So 6 divided by 3 is 2, and 9 divided by 3 is 3. So 0.666 is recurring, expressed as a fraction will be 2 over 3. I want to proceed to B 0.73. So you can see, again, let the fraction be x or any other letter like m. And then the interpretation will be the fraction x, which is the fraction expressed as a decimal, is a recurring decimal. So 0.73. So the dot is only on top of 3, meaning it's only 3 that is recurring. So 3, 3, 3, 3. Maybe I use 1, 2, 3, 4, 5, 6. I can use 6 digits, So you multiply by 10 continuously until when you have a pattern after the decimal point the same in at least 2 cases. So the first case is the one we have here. So the second case is when we multiply by 10. 10x on this side, and the other side you multiply by 10 will be 7.3333. So 6 digits after the decimal point, 6 decimal places. So you see, we don't have any 2 cases where the pattern of the decimal point is the same. So we'll continue with that multiplication. So you multiply the latest one, like 10x is equals to 7 point. That is the one you multiply by 10 on both sides again. So left hand side multiplied by 10 is 100x. Right hand side multiplied by 10 is 73 point. So 3, 3, 3. So 1, 2, 3 again, the last 3 here. So you see the pattern in these two cases is the same. 3, 3, 3, 3. So what you do, you subtract the two cases. So we are subtracting the smaller number from the larger one. So 10x from 100x. So 10x, and this side I'm subtracting 7.3333. You maintain the number of digits of the decimal point. So 0, 0, 0, 0, 0, 0, all of them. But now here I will borrow 1 from 7, take it to 3, 3, it's taken as 10. So 13 minus 7 is 6. And we borrowed 1, so this is 66. 10 from 100 is 90. So 90x. So you divide both sides by 90. And therefore x is equals to, so left hand side if you divide by 90 will be x. So I'm supposed to divide both sides by 90 here. So left hand side 90 cancels 90, I have x. But now right hand side I have 66 over 90. So what you do is to simplify. Both of them are simplifiable by 3. Maybe let me write it up a bit so that we have some space. So x is equals to 66 over 90. So if you divide the upper one by 3, it will be 2, 2, and the denominator will be 30. Again, you can divide by 2, so that we have 11. You divide by 2 is 15. So this is 11 over 15. So 0.73333 expressed as a fraction will be 11 over 15. Yes. So we have the third one here, C. Again, you'll do the same thing. So let the fraction be x or m. So m should be equal to 0.15. So here, both 1 and 5 are being repeated. So 1, 5, that pattern repeats itself. Or it's repeating itself endlessly. So 1, 5, 1, 5, 1, 5. So 1, 5, 1, 5. I will only write the first 6, 1, 5, 1, 5, 1, 5. So you're supposed to multiply by 10 again, continuously until when you have the pattern of decimal point the same in the two cases. So left hand side by 10 is 10x. Right hand side by 10 is 1.5, 1, 5, 1, 5, 1. 1, 5, 1, 5, 1, 5, 1, 5. So I've only used 2 digits of the decimal point. I'm maintaining the number of digits after the decimal point, 6. So you can't see any 2 with a pattern of the decimal point the same. So I'll continue with that multiplication. So I have 100x is equals to 15.15, 1515. So you see here and here, the first one and the third one, the pattern of the decimal point is the same. So I'll subtract the 2. So this is actually supposed to be m. So I'll subtract 1m. It's just written as m, but ideally it is 1m. And the other side we are subtracting 0.151515. So if you subtract, it's subtraction 0, 0, 0, 0, 0. All this one. Now here we have 15. And this is 99. So 99m is equals to 15. So you divide both sides by 99. And so you have m is equals to 15 over 99. So you see both of them are divisible, both numerator and denominator, because now you have to simplify in the simplest form of that fraction. You have to give the answer in its simplest form. So you divide both numerator and denominator by a number that is possible. Like both of them are divisible by 3. So 15 divided by 3. So m here is equals to, so 15 divided by 3 is 5. And 99 divided by 3 is 33. So that is the fraction that is equivalent to the recurring decimal 0.13131313. So that is how you go about it. So you have a few questions here to help you practice. Express the decimals as fractions in their simplest form. We have 0.2 with a dot on top of 2, meaning 2 is the one recurring, and 0.15. Yes, so both of them are recurring. So try, we have 151515. Try and attempt. So that marks the end of the lesson. Until next time, goodbye.